A theory of semantic information. Information has been recognized as one of the major resources that human could effectively utilize for raising their standards of living in an age of information. It is well known that the really useful information for humans should be the trinity of its syntactic, semantic, and the pragmatic information, so as for the users of the information able to know the form, the meaning, and the utility of the information, and thus known how to use it. In in the case of communication engineering, however, only the form factor of signals, the carrier of syntactic information, needs to consider, and nothing to do with both the semantic and pragmatic information. Hence, Shannon theory of information is indeed a statistical theory of syntactic information only, not an entire theory of information at all. Classic theory of semantic information. They define an ideal language model that has five connects. The more the number of sentences that a word can imply in the model of language, the larger the amount of semantic information the word has. The basic idea for semantic information measurement of any sentence in classic theory is dependent on the number of sentences in the language model that can be excluded by the sentence. The most nucleus concern in the theory of semantic information is the meaning contained in the information. This is because of the fact that the users of semantic information should be able to understand the meaning factor of that information so as to be able to effectively use the information for solving problems. The fundamental problem of communication is that of reproducing at one point either exactly or approximately a message selected at another point. Frequently, the messages have meaning. These semantic aspects of communications are irrelevant to an engineering problem. Classic information theory. In Shannon 1948. Source, transmitter, noise, channel, receiver, destination. Semantic information theory, private knowledge and context, semantic transmitter, semantic receiver, and destination. Observation has a world model, inferring deduced fact, transmitting messages. Key. A semantic source tells something that is true. Engineering bits are neither true or false. Goals. More correctness, sent as true, received as true, less ambiguity. Background knowledge, when shared, helps compress the source. Cite information in the form of entailment not addressed by classic information theory. Intuition, by removing synonyms. Pig equals to swine. Theorem, there is a semantically lossless code for source X with message entropy H greater than or equals to H of X equivalent. X equivalent are equivalence classes of X. Other lossless compressing strategies may exist. Example, by using semantic ambiguity. Lossless model compression. Example, using minimal models. Lossy message compression. Sometimes a semantic loss is intentional compress. Ongoing work. Model, sent message, received message model. Example, for engineering noise, copy machine or coffee machine. Semantic mismatch, the source or receiver use different background knowledge or inference. Lost in translation, the word uncle in English has no exact correspondence in Chinese. Note, not all syntactical errors are semantic, neither that all semantic errors are syntactical. Theorem, if transmission rate is smaller than C of S, semantic channel capacity, semantic error free code exists. Cs equals to suppress of I of x to y minus h of w by x plus hs of y. Extension: first order language, probabilistic logic, inconsistent KBs, misinformation, paraconsistent logics, lossy source coding, clustering and similarity measurement, semantic mismatches. Application: semantic compression for RDL OWL, semantic retrieval, example extending TF into IDL. Conclusion: the most fundamental purpose for humans to acquire information is to utilize information for solving the problems they are facing. For this purpose, to understand the meaning of information, semantic information, to evaluate the real value of information, pragmatic information, and thus to create the strategy for solving the problem are absolutely necessary. The important applications of semantic information in the field of knowledge expression and organizing knowledge based architecture, learning, understanding, cognition, and strategy created has been re explored, and the framework of semantic information theory has been formulated. Thank you.